Hi everybody, my name is Mtwana Nkosi. Excuse me, let's get started. So, before you get started with the question, make sure you read your question very careful and very careful, because if you're not, means you're gonna misunderstand your question. Meaning you're gonna means you're not gonna give it the accurate answer. So read your question very careful. So before we get started, right? I just want to mention this is very crucial. Okay, so if you FaceTime here, you have not, please come right here, subscribe to the channel, because if you do that, then it's very important, because every time when I upload a new video, you're gonna get the notification automatic. And apart from that, okay. So I'm trying to Bantu, and then subscribe to the channel, like I say here, right here. But apart from that, we have a program, which is apart from the academic. I have a feeding program, where you can get all the video where we feed and raise and help our people, because like I say always, if we're not gonna do for our people, especially vulnerable people, then nobody can do it. So you, me, and other people, we can do it. Okay, and that's how you get to see all this all this program whereby we feed homeless, or we help homeless people, feeding program and all this stuff. Also you can do some kind of donation, and apart from that, also you can go to online store and purchase some of the merchandise that we have and different products. Now let's continue the question. So the question here say, like I said, read careful, because if you're not gonna read careful, then meaning you're not gonna get it right. So read your question very careful. It's very crucial. Now let's say here, this is a diagram. So what type of diagram this? Okay, so let's say a diagram of an electrical machine shown below. Electrical machine. So I've came up with this diagram because this is very important. Let me start with the, okay, let's read the question, then we're going to come to this diagram, and then I'll explain to you in depth. Now this electrical machine, we have a coil, means there's a coil here all the way, but this coil is like this, but it seems like this coil is going to start to either to rotate this way or to rotate that way. But what's going to influence it to rotate? Look, if you look careful here, we have a cell, because it's only one, so we have a positive and negative. This is cell because it's one, but if it's more than one, it's gonna call what? Battery. But it's not, for now, it's just cell. So what happened to that cell? So it seems like this person here, somebody's gonna place a battery. If you place a battery, and then that coil is gonna start to rotate. So now we want to find out, let's say, which direction is gonna rotate. And remember, the moment you place a battery here, this coil is gonna start to rotate, like either this way or that way. But I'll tell you now how you're gonna identify which direction it's gonna take. And the moment you rotate, the magnetic flux is gonna start to move from north to south. You see what I'm saying? The magnetic flux is gonna start to move from north to south, and then from that, meaning okay. So now let's go to the question phase, because I don't wanna. Okay, and then meaning we convert electrical, because we place a battery electrical, and that electrical is going to produce mechanical. What that means? Look, because when you place a battery right here, means battery is more of electrical. So now we produce something mechanical, like when it rotates. That's mechanical. See? So now let's come to the first question here, because okay, let's go to the first question here. They say is the machine a DC motor or DC generator? This is the motor, because we can see here the moment you place the battery here, like you say, see, you place the battery, what happened? It's going to start to rotate. So it's the motor. It's a motor. So we say this is the motor. That's our answer. Now, write the energy conversion that take place while the machine is in operation. While the machine operates, meaning how did the machine operate? The machine operate because now you're going to have to place the battery. When you place the battery, means that's electrical, and then electrical is going to produce the rotation, means electrical to mechanical. That action of rotating, we call it mechanical. Okay, so now we type of the energy conversion, so it's going to be electrical to mechanical. Okay, electrical to mechanical. See, now let's go to see. They say 1.3. Write down the name of the component A. See, the name of the component A, you call it split ring. This A here is split ring. This stuff is split ring because split ring. Split ring. Or sometimes you can call it what? Commutator. Commutator. Okay, that's a split ring. Commutator. Let me write here bigger. T-A-T-O-R. Commutator. Commutator. So you could say split ring / commutator, or you can say split ring commutator, both. You see what I'm saying? If me, I'll write them both, split ring commutator. Okay, so that is for name of the component A. Okay, but not all the time. Remember, they're gonna ask like this. Sometimes they may ask, for example, what about this one? These are brushes, like this stuff here. Those are brushes. But split ring commutator, this stuff here. See, even here, say, oh, this stuff here is split ring commutator. See here, label. This is split ring commutator. This one here, split ring. And you can say it kind of split, but these are brushes. Sometimes they could show you the other. So, okay, what is it? Those are brushes. And these are coil. This is a coil here. Excuse me, the coil. Okay, even though it's not part of the question, I'm trying to explain. Okay, now so now the next one, they say, okay, which direction will the coil shown in diagram rotate? Choose either clockwise or anticlockwise. Let me start from here first. Let me explain to you how you're gonna know whether it rotates clockwise or anticlockwise. Look, if you can look careful, we know this is better here because there's more than one cell. See what I'm saying? Because like I always say, if you have something like this, let's say this is a cell because it's just a one. But if you have more than one cell, we call it battery. Like for example, this is a battery because more than one cell. And remember, this is positive, this is negative because the longer side is positive. Okay. So now if you look careful, we have a battery here, and this is same with that. See, it's just a motor, DC motor. So here is positive. If this side is positive, look, if this side is positive, look, just know. If this side is positive, okay, let me show you the easy way. That side is positive, right? You see the side here is positive here? And this side is going to be, this coil is going to rotate that direction. So it's more like it rotates on the positive side. Let me put it that way. It rotates on the positive side. But if you come to this side here, so in other words, this coil here is going to be what? Clockwise. For this one here, the one I'm explaining is clockwise. Because why? It's positive right here at the silent battery. And this coil is going to rotate the same positive side. Oh, okay. So for that case, for this diagram is clockwise. Now, let's come to this diagram. Look, this is positive. So what's going to rotate? We say it's going to rotate on that positive side. Means it's going to be like this. Oh, so for this case here, is going to be anti-clockwise. Because, okay, some people don't know what's clockwise and anti-clockwise meaning. Look, this is the watch, right? The direction of the watch is clockwise. Like, let's say this is the watch. The watch always goes that way, this way. So that direction, we call it clockwise. Anti-clockwise means like opposite of how the watch goes. Like the watch goes this way. That's what we call clockwise. So now the opposite of the watch side, I mean the other direction, the reverse of it, like if let's say the watch goes this clockwise moment, clockwise side, means the opposite side direction we call anti-clockwise. Anti-clockwise. So now for this case here, so we found out like, okay, so this stuff here is positive here. See, so since it's positive means the coil is going to rotate that way, which is what? Anti-clockwise. Oh, okay. So now it's going to be anti-clockwise. The answer is anti-clockwise. Sorry about that, Pammy. Somebody just comment in the middle of the session. Okay, anti-clockwise. Now, let's go to the next question here. Now, they give us an electrical device which has a mark of this one. So, this is the power. And this one here is potential difference because it's measured in watts, so we know it's power, even if they don't tell us, but we know it's power. And then this 220 is a voltage. But look, electrical device mark. Okay, now let me say this, very, very crucial. Okay, let's remove this one because now we don't need this. We don't need that one. Look, so we say, okay, let me show you this. Okay, you see this one here, right? This is power average, and this is potential difference, what? RMS. How do you know that? Look, RMS. Every time when they give like that, for example, this, okay, how do you know this power? Because of the unit. W meaning watt, so we know it's a power, okay? And the 220 volts means that's a potential difference, and they will represent potential difference of voltage by V. Now we have a formula that you have to know. They give you all the time in exam, okay? So this is a formula here. Oh, no, it's not that one. Sorry, my apologies. With the formula, my God, what is that? Just a second. I want to show you the formula so you know it's in the formula sheet. Okay, it's not there, but I know. I can just tell you what. Okay, yeah, this one right here. My apologies. Yeah, this one right here. Okay. Okay, so this formula is very, very crucial. Look, you need to know this. Power average, all of this, like all this, you can use any of the, it depends on the information. So power average equal to potential difference, RMS, times current RMS, okay? So come back here. I'm going to say then, I'm going to say now, because you know why I'm applying that? Because they give me here, they give me power average, and they give me potential difference, RMS. So another thing you should know, look, power always equal to IV. That one you memorize. Power equal to IV. Power equal to, just memorize that part. Power equal to IV. So I'm going to say here power equal, my power equal, okay, my power equal to I, but power equal to IV. That's what you should know. But my power they give to me is power average equal to current, which current? RMS, just like I show you there in the formula, RMS times potential difference, which is that one, but I will take the RMS. So power we have, which equal to 200, and then also potential difference I have. So and then I can find the current because I'm 1 divided by potential difference RMS divided by the RMS. This and this cancel. So now current RMS, which is this one, equal to this power divided by the potential difference, power average, which is given, divide by this one here, potential difference, the RMS. So we can simply plug in the calculator by saying our power equal 200 divide by 220 what? Voltage. And then you divide these two here, it's going to give you 0.909 ampere. Okay, so now we already have our power RMS. Oh, okay, so we have a power. Let me write here power. No, we have a current RMS. Current, my apology, RMS equal to 0.909 ampere. Okay, so we got that one. Then what do we need? So on the first question, they didn't ask us that. See? Oh, I didn't even read the question. I'm supposed to read the question, man. Okay, no problem. The first part they say, anyway, I'm going to use it anyway. Okay, define the term what? RMS. So RMS, see, voltage So we say the definition RMS, they say define RMS voltage. So RMS voltage, the RMS voltage, see, in the value of AC, or you can say RMS voltage, this is the direct current potential, either DC or direct current potential. You can simplify it in a book because it's just a definition. Potential difference voltage, that's what we say potential difference, because when you say voltage means potential difference. That's what we say RMS voltage is the direct current potential difference. So this is the potential difference of direct current, which dissipates, okay, which dissipates, which one? Dissipate the same amount of energy as a alternating current. Oh, dissipate what? The same amount of current, same amount of energy, same amount of energy. See, some amount of energy. Energy, you can say heat, because when you say heat means it's energy slash heat slash power of alternating current. See what I'm saying? So this is a voltage, this is a DC potential difference. Oh, so RMS voltage, this is a DC potential difference, but it's gonna dissipate the same energy as the one which is in alternating current. It's going to dissipate. So this is a potential difference in the direct current, which is going to dissipate the same amount of energy, you see, or you could say heat or power as the one which is in AC current, alternative current. Now let's go to the next one. Let's go to our calculation now. But remember, I started already with the calculation. Oh, let me just do it again, no problem, because you might lose the hang of it. You know, I don't want you to say, man, I gotta go. Okay, now we go. So we did already, we said they give us what? Power, and they give us potential difference. So we know power AV from the formula that I show you. Power average equal to, power equal to IV, we know. Current, do you have a current? No. But RMS times potential difference RMS, which I did already. I just said it before, just a few minutes ago. Okay, so then we say, for now, potential difference I have and power I have. What is our power? Our power equal to 200. Equal to current. Do I have a current? No. Potential difference do we have? Oh yes, we have 220. Voltage divided by 220. Divided by 220. This and this cancel. So current RMS, if you divide these two, is gonna give us 0.909 ampere. Okay. Now let's go to the next one. Like I say, man, if you face time here, man, please come here to before we need to finish that question. But come to this platform here. Is on YouTube, Instagram, and all the social media, so you can see what we do for the community. It's very, very crucial. Also have my online store where you can support our movement and our program and awareness. Okay, now we go. So now you get the current, but that's not the end of the question. See, that's not the end of the question. Now they want you to get the resistance. Oh, it's easy. From the Ohm's law, we know from the Ohm's law, potential difference equal to IR. So you want to get this resistance, but this V is RMS, and this I also the same thing is RMS. But resistance is just equipment, so let's just say resistance. So we have that, and we have the given. What is our V? Our V equal to 220, and our I we just obtained is 0.1 right there. So we can get resistance by saying our V we have, what is our V? 220 equal to 20 V. Let's write the units also in trace. Equal to, okay, let me just say this. What am I doing right now? V220 equal current. Do you have a current? Yes, we have, which is obtained here, 0.909 times resistance. Do you have resistance? Oh no, that's what we're looking for, because they say find the resistance of a device. So now I can simply divide by 0.909 divided by 0.909. That one cancel. So our resistor equal to, take 220 divide this 220 divided by that. Okay, so if you want, you can use a calculator. See, you can use a calculator easily, and then you can say plug in the calculator, and if you plug in the calculator, that one is way easy for me, you know. Plug in the calculator, man. Say 220. I'll come and clean this one, so it's okay. Fraction 220, and then you come under and divide by 0.909 and get an answer. What is the answer? Our answer, just put HD here, and then it's gonna be 242. Okay, 242. Oh, wait. Let me do this. I made a mistake. Sorry. So I'm supposed, okay, let me come here and put a clip because it's not visible. My apologies. Okay, let's plug in a calculator. So I'm gonna say come here, clean, and they go to our fraction, and they say, okay, let's divide. What is the divide? Okay, so we say we divide 220, come to 20 right here, and then they come with the denominator, oh, no, we say 0.909. Of course, yes. Now we say equal. So plug equal, and then come to the SD here, and it's gonna give us, oh my goodness, how do I say that? Okay. Why does it give like that? It's crazy. Okay, let me clear my calculator. Sorry about that. I don't know what happened. Okay. Come here and shift, and then you clear your calculator. When you calculator does some funny stuff, just go there, and then number 3, say equal. You just ask for equal, and then just say AC. Reset everything. Okay, now let's come to the fraction here. 220. My apologies. Sorry about that. And then divide by 0.909. 909. And then just say equal. SD, I hope he's not going to do it again. Oh, yes. Whew. Okay, no problem. So the answer is 242. It's 242. Simple as that. You see? Just ignore the rest. I don't know what my calculator does there, but the answer is 242. Okay? So answer is 242. Okay? I want to go to 242. Now, let's just continue and say let's go to the next part. So we have our resistance 242. Okay? So our resistor we have 242. 242. Our resistor is 242. Finally, the resistance here equal to 242, but the unit of resistance is ohm. Okay, now let's go to the next one. Okay, so for the next question here, they say, this one here. Calculate the energy dissipated. Oh, now from here, this device is now connected to AC. Oh, so we connect this device to the certain voltage, but that voltage of AC. But they say also we have the energy dissipated in 10 minutes. And what is the one? The one find the energy dissipated in 10 minutes. Dissipated in 10 minutes. Okay. So we want to get the energy, and they give us voltage. So remember we have a resistance. Okay. So let's write here our resistance. We have equal to 242. We just got it from the previous question. They give us voltage. Voltage RMS equal to now is 150. Okay, and also another thing, they give us time. 10 minutes. But this time change it to seconds. So change second means multiply by 60. It's going to be 600 or second. Okay, so let me show you something how you get energy. To get energy, you say energy always equal to power times time, times change in time. That's how you get energy. Energy take your power, multiply by time. Energy equal to power times time. But power, we can get it. Do you have a power? No, we don't have a power. But what do we have? We have a resistance, we have a voltage, we have a time. So this time we have. So I can just break this power by saying, but a power equal to IV. We say before, power equal to IV always current times voltage. So we say, okay, power equal to current times, so this is going to be current of RMS times voltage of RMS times time which we have. So we'll replace this power because you know power equal to IV. Now we go. So now we're looking for the energy. You see what I'm saying? Now we say here, do you have a current? No, we don't have. So the only problem here to get the current. Do you have a voltage? Oh yes, we have this one here. Do you have a time? Oh yes, we have. Our time equal to 600 seconds. 600 seconds. So let me find the current now. How I'm gonna get current? So I'm gonna say now use Ohm law. So we're gonna leave this question, or we can just say power. Okay, current do we have? No, we don't have. Times voltage. Oh yes, we have voltage. What is our voltage? 150. Times time times 600. So let's call this what? Tie equation. Okay, co-phase equation. So the problem is to find the current of RMS. How are you gonna get the current? From Ohm's law. Ohm's law say V equal to I R. See what I'm saying? V equal to I R. But now we deal with the RMS. Everything is RMS here, okay? So it's a potential difference of RMS equal to current RMS times V equal to IR time resistance, which we had already. This is our resistor. Potential difference is 150. And then we can get current of RMS. How are we going to get current of RMS? We say, so we say that potential difference have 150 current RMS times resistance we have. Our resistance we had it already, 242. So we can get current of RMS divided by 242 throughout, divided by 242 here, divided by 242 here. This one this will cancel, and then divide this 2 is going to give us current of RMS. So current of RMS equal to our current equal to 150 divided by 242. 150 divided by 242 is going to give us 150 divided by 242 is going to give us 0.602. 0.602 ampere. So this is the current of RMS. So this current here we're going to come and substitute here. So then we're going to say substitute this into this equation because the problem was what was current. So finally we're going to say energy we're then looking for equal to current equal to this one here 0.602 times potential difference 150 times our time 600. So in other words you can substitute here simply. Means here which we 0.0 something, and then this one here is that one, and this one here is that one. So plug in the calculator. If you plug in the calculator, that's gonna give you okay, let's plug in the calculator. 0.6. okay, come and plug in the calculator quick. Excuse me. Plug in the calculator quick. So you come here and we're gonna say let me do this one first. Okay, like that. Okay, let's plug down the calculator. So come here, plug in the calculator. So we say okay, clean your calculator, and we say 0.6, 0.602, 602, and then we multiply by 115, and then also we multiply the end by 600. Oh, 600, sorry. Okay, 54180. 54180. 54180. So this is gonna be 54180. 54180. So we come here, we say, all right. So our energy could 54180. So our energy equal to because they say here calculate the energy, it's gonna be 54180. 54180. See, 54180, and this, remember, is gonna be watts because it's energy. So like I say, man, you know, if you FaceTime right here, man, please just come to this program here, subscribe and see what we do for the community. You know what I'm saying? And this project is just to raise awareness because, like I say all the time, if we know what to do, then nobody can do. So we don't want to have to change our community, uplift our people, and equip them with the skills. Okay, that's why I decided to do this type of giving back. You see, it's almost free. See, with all this equality, you know, the intellect that I offer to the community, and you know, for the people who need our time and skills, and apart from that, you see, just come here, subscribe, and they share. And you know, I love my brother from the continent of Africa. It's not only African continent, all across the globe. So if you're from any party, you know, just like a lot of messages I always receive from the student from Louisiana, Chicago, Nigeria, Ghana, man, South Africa, man, my brother and sister, also from South Africa, KwaZulu-Natal, man, I said and everywhere, man. They always say, like, man, Mutuana, of course, you're doing very well. And thanks a lot for your support, because without your support means these cannot go, can never go. So you play very key important in sharing these platform. And just like you see here is me right there, man, when I was 4th grade. That's me when I was 5th grade. This is my other friends and all this, my younger friend. This is brother, he's a Rastafarian, you know, since when we were baby, okay? And then here, come and subscribe to my old social media. You could Facebook, Instagram, and YouTube. I'm trying to see. Go subscribe right there, okay? This is another channel where we do the kindness, you know, of giving back to the people, inspire people, especially vulnerable people, just like I say, because, you know, it's said that we just wait for people come and do for us while there's things that we can take initiative ourselves, okay? This is why I take on the forefront to do something that can inspire you and other people too. So thanks a lot for all your support, and also come and subscribe to this platform you're watching. Without forget to subscribe here in another YouTube channel called Mtwana. Because it's very, very crucial. See what I'm saying? And this one is my mama right here, and that's me, and that's her friend, okay? So thanks a lot for your time, and I'll be seeing you soon. Peace in the mouth. Peace.